So, predicting the compound formed by two main group elements, you're going to be asked about any two elements in the periodic table. Okay, so just remember the general rule is metal plus non-metal is going to give you an ionic compound, right? So, how do you write the formula for any ionic compound? Well, you've got to know what group those atoms are in to be able to predict the common charges on their ions. Okay, and then you'll write a neutral formula, their empirical formula if you like, which is balance between the cation charge and the anion charge. That will decide the stoichiometric ratio of the two within the compound. If you have two non-metals bonded together, well, bingo, that is where we are going to form our molecular compound, which is joined together with covalent bonds. Okay, so covalent bonds is the sharing ones, right, that we've been dealing with our Lewis structure. So if you're trying to predict what the chemical formula is just based on non-metal versus non-metal, it's best to look at the Lewis symbol, okay? If you look at the Lewis symbol, you'll be able to tell the bonding capacity, and based on that, whatever's got the highest bonding capacity wants to form the most number of covalent bonds is going to go in the middle, and it's going to form enough covalent bonds to share enough electrons to satisfy the octet rule. Remember, each of these elements forming a molecular compound is sharing electrons to try and get its complete octet. And then occasionally you might have a bit of a red herring there, throwing in a metal plus a metal. That's metallic bonding. So we are not really dealing with that in general chemistry, but so that would be a neither option, I guess. Ha. Okay, so let's see what we've got. Element 1 is potassium, element 2 is bromine. So let's find them on the periodic table if that helps you out. So potassium, definitely a metal, going to form a cation. Bromine, definitely a non-metal, going to form an anion. So remember, the groups help you know your predictable ion charge. So group 1 always forms a +1 cation, group 2 always forms a +2 cation. Group 13 usually is going to form a +3 cation, okay? And then group 14, it's going to be either or, but generally you're talking about a -4 anion unless you're getting down to tin and lead, because we go from non-metal at the top to metal at the bottom. So at the top -4, at the bottom +4, okay? And then we've got nitrogen -3, oxygen -2, fluorine -1. Noble gases don't want to form ions. Okay, so we know our predictable ions on the periodic table. I'm going to keep these away from Lewis symbol notations right there. So we can be pretty happy that potassium is going to form a +1 cation, bromine is going to form a -1 anion, so they will form the ionic compound 1-to-1 ratio KBr, potassium bromide. So definitely ionic, and we are going to predict that'll be KBr based on the charge considerations of the ion. Okay, so calcium and iodine. Calcium is here in group 2. Iodine's over here in group 17. So calcium in group 2 forms a calcium 2+ cation. And we've got the iodide ion, I-. So it's going to take 2 iodines to balance 1 calcium 2+. So calcium and then 2 iodines, CaI subscript 2 will be our ionic formula. Oh, right. So don't forget that, right? We did that way back in like chapter 3, chapter 4, whatever it is, a while ago. Okay. So nitrogen and iodine, two non-metals. Here they are. Nitrogen's here, and we already met iodine here, right? So two non-metals, they're going to do some molecular compound making, right? So it's going to be covalent bonds. So for your covalent bonds, I think it's very helpful if you just draw your Lewis symbol. Okay, so nitrogen is in group 15, so it has 5 valence electrons. That is coming from its 3s2 3p3 configuration. Okay, so 2 plus 3 gives me 5 valence electrons in its Lewis symbol. 1, 2, 3, 4, 5, like so. And iodine over in group 17 has got 7 valence electrons, right? It's got a, let me count, 1, 2, 3, 4, 5 S2. Don't care about the D, but 4D10 are in there somewhere. 5P, 1, 2, 3, 4, 5. So P5, 5P5 plus 5S2 gives me 7 valence electrons. 1, 2, 3, 4. Oh gosh. 5, 6, 7. Okay, so in terms of bonding capacity, then iodine, oh, that's not what I wanted to do at all. Iodine only wants to form one bond because it just needs to share an electron here. So iodine has got a bonding capacity of 1. Nitrogen wants to form a bond here, wants to form a bond here, wants to form a bond here. So nitrogen's got a bonding capacity of 3. So if I was going to guess the Lewis structure, I would assume that those 3 places where nitrogen wants to form a bond is where it's going to share with one iodine atom to form a bond. So if I draw my Lewis symbols for my elements, and you know what, I'm going to give nitrogen the pink ones, and then I'll change the color for iodine. So 1, 2, 3, 4, 5, and then iodine's coming in with their 7. Okay, so 1, 2, 3, 4, 5, 6, and the 7th is going to be sharing here with the nitrogen. Okay, so same for this 1, 2, 3, 4, 5, 6, and then the 7 will be forming a bond here, and same with this one. 1, 2, 3, 4, 5, 6, 7. This is looking like one of those are you colorblind pictures now. Okay, so you can see, kind of, sort of, that these would be the bonding electrons. Yes, I got them all. Forming single bonds between nitrogen and iodine, and then each iodine will have 6 electrons in lone pairs. So I would, predict the formula Ni subscript 3 for the nitrogen iodine bond.